we're going to look at applications for logarithms because truly nobody does all this math unless they have a reason. So we're going to look at reasons. And I want you to look carefully at the formulas. We're going to use 1, 2, 3, and 4. Five and 6 are kind of like alternatives to 3 and 4, and I'll explain that in a second. So when you look at 1 and 2, A stands for the amount you have when you're done. P is the principal. So if you were to go to the bank and put some money in, right? You were to go put some money in the bank. Wait, it's P-A-N. That would be your principal. You stick it in the bank for a while and later you get more back because they pay you interest. This is the amount at the end right there. Right? Or if you borrowed this much money and you were paying interest, then that's how much you would owe. It's important to keep those straight. A lot of times if they give you dollars, you always want to put it on this side, and we're not always solving for that. R is the rate. T is time. Now, this is crucial. For banking purposes, time in years. So if they gave you 6 months, you would have to call time 1/2. Okay. Now for the other two, half-lives and doubling times, time doesn't matter. If they give you minutes, it can all be in minutes. But these formulas are specifically designed with time in years. So if it's 3 months, that'd be 0.25, right? You have to convert that. And then N is the number of times per year. And the numbers are the same over here, except you notice we have an E in there, but that's just in your calculator. So N is the number of times per year. If it's compounded yearly, that would be 1. If it's compounded quarterly, that would be 4. If it's compounded monthly, that would be 12. Does that make sense? Very important that you know what these stand for. Now I want you to look at half-life and doubling time. Do you notice that that's actually the same formula? Let's look at it. Except this is half-life, so it's got a half in there. This is doubling time, so it's got a 2. But then this is the initial amount, right? T is time. H or D, the bottom number, is just how long does it take this thing to double, or what is its half-life? So really, those are the same formulas. They're just separated out for you. So let's start and we'll just work these out. Now, the easiest way, if you want these to be easy and not make any mistakes, the best thing you can do is, first of all, choose your formula, then identify all your variables. Then they're really easy. So let's look. If interest is compounded monthly, find the account balance if $1,000 is invested for 5 years at 9.5% interest. Now, I've got a huge percent there for the simple reason, if you did the percents that we have right now, when you get the answer, it's like 2 cents more. You can't even see it. So note that this is a big percent. Is the percentage that high right now if you put money in the bank? No, it's so low. If you had $20,000 in the bank, you might get 70 cents a month. It's very low. But we're going to play with higher numbers so we can see a difference and see what our math does. Okay, so compound interest, the word compounded tells us that. So I'm going to identify all of my letters, especially the A and the P, because that's going to tell you whether the amount goes here or here, right? And it might take you 10 seconds to write this information down. That keeps you from doing the problem over, which saves you 5 minutes, right? So find the account balance if $1,000 is invested. Is that an A or a P? You have $1,000 and you're going to invest it. So is that A or P? That's P. For 5 years, that's time. 9.5%. Now we have to convert that to a decimal. So divide by 100 or move the decimal over twice, right? N, compounded monthly. So what is N? 12, right? So identify your letters, then pick your formula. This will allow you to see if you can plug it straight in, or if you need to do some fancy math to it. Now that is 12 times 5, not 12.5. So I'm going to rewrite this. Now, if I were doing homework, I'd go straight to the calculator. But in my notes, I want, oh wait, I wrote N there. What N should be 12, sorry. In my notes, I want to get it written. So it's exactly, what is 12 times 5? I purposely put this here so later when I look at this, if I'm doing homework, I don't think it's 12.5, right? I don't want to think that I put in that. So now that's ready to go straight into your calculator. Now everyone knows how to put a fraction in, right? So just type it in exactly like it is. And make sure that you get what I got. Make sure you use the calculator, because if there's some error there, everything would go wrong, right? Easy, right? Are we good? Give me the bat signal when you get it. That's just a thumbs up. Yes, sir? Oh, 1 cent. I wrote it up there. That's 1605.01. In the olden days, we wrote little numbers up there, and I was getting close to the edge of the paper, so. I don't think y'all have ever seen money written that way. That's really old-fashioned. People at home, send me a thumbs up if it punched into your calculator right and you don't need any help. Yay, Emerson. Yay, Nikki. Yay, Morgan. Coming. Mia. Cass. Caitlin. Andrew. Yay. Is everybody else okay? All right. Not bad, right? That's easy. Okay. If interest is compounded continuously, when you see continuously, that is this guy right here. I call this the money laundering formula. How come? Does anyone see what I see? What word do you see there? Pert. You know that old Pert shampoo? Wash your hair, right? No? Okay. Anyway, P equals ERT. So this, we don't need to identify E, correct? E is not a variable. E is, it's like pi, it's an irrational number. So now we need to know E, A, P, R, and T. Now everything is the same because we're talking about, oh, I should have said exercise 1. Find the account balance after 5 years. Time is 5. The rate is the same. The principal is the same. Let's see what this looks like. A equals. We love this formula. It's very easy to plug in. Right? So plug that in. If you need the E button on your calculator, you want to use second ln, okay? Second ln is going to bring E, and it's already going to have the power there for you. So use Did you get more money? A little bit more, right? Now, if this Was there longer, you'd get more, or if you had a bigger amount, it could matter. Are we doing okay? Okay. All right. How long does it take $1,000 to amount to $1,500 if it is invested at 8% compounded quarterly? This is kind of a question that you may deal with more. This is something maybe your parents thought about when you were born. They're like, we have 18 years to get ready for college. What are the interest rates? How much do we need to put in? These are kind of questions that we look at, right? Or let's say you were saving up for something and you thought, okay, how long do I need to invest this till it turns into what I need? So we're going to go to the compound interest formula. So let's identify, we're going to need A, P, R, N, T, right? There's 5 letters that we need. So let's see, how long does it take 1,000 to amount to 1,500? Which one of those is P? That's P, right? Because that's what you're going to put in the bank. Now you want to get 1,500 out. It is invested at 8%, compounded quarterly. Remember, this is your N, and quarterly would mean 4 times per year, right? So now we go straight to our formula up there, right? 1,500 equals 1,000 times 1 plus 0.08 over 4 times 4t. What's different about this problem? This one has an issue. This is the reason it's in this unit. So a variable as exponent, right? If you have a variable that's up in the sky as an exponent, you will need what to finally solve this problem? What unit are we in? Okay, so when you see a variable up there that you don't know, that's when we know we're going to have to solve this using logarithms. We don't need it yet. Can you clean this up a little bit? There's a 1,000 sticking out to the side. Can we divide both sides by 1,000 and clean that up? Let's do that. You always want to get rid of the thing that's raised to a power. If there's anything in front of it, we want to get rid of that. What's 1,500 divided by 1,000? Is that 1.5? And write all of these steps in your notes. You're going to get a little faster as you start to work. All right. So now how does 1 move an exponent from here to the front so you can work with it? How do you get it down? With a log. A log is like a big stick. Knock it down. So we are going to, and I'm going to write out every step in your notes. So if I log one side, I'm going to log the other side. And at least one time in your notes, don't skip any steps. Now, what good did that do? That just made it worse. What does that allow me to do? Now the 4t can come where? To the front. So now I have log 1.5 equals 4t log 1 plus. Can I do 0.08 divided by 4? Can we take the 1 plus the 0.08 so we don't have to keep writing that down? What is 1 plus 0.08 over 4? That's 1.02. I'm going to go, I don't want to keep writing that. And now how are you going to get that t by itself? Yes, I'm going to get another color. I'm going to divide through by 4 log 1.02. And where do you find the fraction button on your calculator? Alpha y equals 1, right? Use your fraction bar so that you don't need parentheses. If you don't use a fraction bar, you're going to need parentheses like that around your log. And you should get 5.119 years. And remember, when we're dealing with exponentials and logarithms, we want to always keep 3 decimals unless it's something that we can't keep 3 decimals for. If it's asking you about money, we know that's 2 decimals. Or if it asked you how many people will be there, then we would have to round, correct? Because we don't have parts. But if it's anything that we can have a part of it, like a part of a year, then we're going to put down the decimal. So it's going to take 5 years at this interest rate. Okay? Any troubles? All right. Moving on. Okay, here's another one. Now, I want to point out, if we're dealing with money or half-lives or doubling time, those are standard formulas that work. If I give you some other topic, like the next problem, that doesn't apply to those, then I have to tell you the formula, right? Not everything in the world.
Can I go to the tech job?
Yes.
All right.
We love technology problems, don't we? Okay, so notice in this problem, they're going to give you the formula because it's not a money and it's not a doubling time. So there are lots of things in the world, especially in finance and business, where sales and things like that have their own formula, right? Okay, the number of hits of Y hits a new website receives each month can be modeled by Y equals 4,080 e to the KT, where T represents the number of months the website has been operating. In the website's 3rd month, there were 10,000 hits. Find the value of K and use this result to predict the number of hits the website will receive after 24 months. This is applicable, right? Do you think the world uses websites these days? Yeah, you can't buy anything, right? Everything's on a website. So it's really important. How do websites run? Do you pay when you go on and you look for stuff? No, what comes up on the side of your computer? Ads. Ads are there. That's how it's paid for. So are people going to advertise if a website's not getting hits? No. So do people keep track of how many hits a website gets? Oh yeah, you know they are, right? So this is very applicable to today's world. So I'm going to write this down. I like it out here in my own handwriting. That also helps me remember what variables, because this is a different formula. Okay, in the website's 3rd month, there were 10,000 hits. Y is the number of hits. So 10,000 equals 4080 E, and this is 3rd month. So that's 3K. Remember, we use the time given, unless it's banking, which is years. Just make sure that it's consistent. If they had said 2 years here, you'd need to convert it to months, because if this is months, both of them have to be the same unit, right? So you can see here that we're going to need what? Let's divide by 4080. Punch that into your calculator. And what do we get? And then what are you going to do? We're going to take are we going to take the ln or the log? ln, because it's E. So we're going to say ln. You could already, right, equals what? What's going to go over here? Let's cut it down a little bit. 3K, because that's going to come to the front. There, I kind of did that in one spot. Now, what do you really like about this equation? You already know the answer to this. What is ln E? If If you don't remember, punch in just LNE by yourself. No, you have to know this guy. What's LNE? LNE is 1. So you like that. Now we can divide both sides by 3. So type in ln and this, right? Divide by 3. And tell me what k is. Right, we'll divide both sides by 3. So ln 10,000 over 4080. Enter, divide by 3. And k is what? 0.2988. Make sure you're actually typing this into your calculator. If you don't practice, then when you're faced with a problem, you're going to look at it and be like, because as you could see from this problem, I can give you any number of topics about anything, as long as I give you the formula that goes with it, because you don't know every topic in the world, right? Every website would have a different formula, true? Yeah. Now, if K is 2988, use this result to predict the number of hits it will receive after 24 months. Now I could say Y equals 4080 E to the 0.2988 times 24. Now plug that in and see how many hits you'll get. And I can't, if you plug in 0.299 versus 0.2988, you get a slightly different answer. I'm going to punch that in because I wrote it down when I put the key online, but I don't remember what I wrote. So 5, what is that? Now, can you get a part of a hit? No, hits has to be a counting number, right? So we're going to round that up. So 5,309,734 hits. So that's quite a growth, right? And do y'all realize anytime you have an exponential, a number in the exponent spot, if that number is bigger than 1, you're going to grow fast, right? Exponentials grow very fast compared to logarithms that grow very slowly. Are we okay with that? This isn't bad, right? It's kind of interesting. Ooh, only one more page of notes. Let's look at this one. Oh, the growth function ft blah, blah, blah describes the number of people who have become ill with influenza T weeks after the initial outbreak in a particular community. How many people will became ill with the flu when the epidemic began? When the epidemic begins, what does T equal? No. At the very beginning, T equals what? We call it ground 0. So if we say at the beginning, time has not started yet. Okay. So let's plug that in. You know that the CDC is frantically working on these kinds of numbers right now, right? With COVID and then with the vaccine, after the vaccine, people who didn't, I mean, they're studying constantly, right? We're bombarded in the news every day with how many more. Now that's e to the negative t, that's 0, right? So let's punch that in and see how many people have it at the beginning. We don't know they're sick. See if you get 19.996, which of course I would not write that answer if it says how many people. Please make sure you're actually using your calculator so that later you're not like, wait, where's this button? 20 people are sick. Maybe they just flew in from somewhere and they're getting off the plane and they're infected. Now, how many people were ill by the end of the 4th week? So now we say, okay, 4 weeks have gone by. So now you're going to punch that in. And what do you get here? So in 4 weeks, there's 1,080 people infected. Now, would every different type of cold, flu, chickenpox, whatever, would this formula be the same for all illnesses? No. So they have to figure that formula out based on how rapidly the bacteria divides, multiplies to make more, and how communicable it is, all those kinds of things, the vector. Definitely a lot of work in figuring this out, right? The CDC is busy. Is that okay? All right, let's look at the next one. Use this formula that gives the time in years for a population with a growth rate K to triple. Nigeria has a growth rate of 3.1%. How long will it take Nigeria to triple its population? Do you think the 3 there is because it's tripling? You think that would be 4 if it was quadrupling, something like that, right? So T equals ln 3 over 0.031. Not hard, right? So you're given formulas, you just have to read the question and figure out your variables. So what does time equal? Punch it in. If I punch it in, I got this. So very close to 35.5 years, right? Are we okay? All right, 2 more will be done. All right, a certain population of bacteria doubles every 3 weeks. The amount of bacteria in the population now is 10 grams. Find its size in 7 weeks. So let's write down doubles. Doubles. Again, this is one where I want to be very careful in identifying my variables, because the 2 things people get mixed up are the A and the I. As you see a number, you want to type it in. So the amount of bacteria now is 10 grams. Find its size in 7 weeks. T equals 7. It doubles every 3 weeks. Find its size in 7 weeks. So we want to find A. I promise if you take just a minute to think about what you're doing, it will keep you from making mistakes and save you time. So we're going to say what? A equals 10, right? Okay. Punch that in on your mark it, set, go. Can you think of an application where we really study bacteria? How many of you have ever eaten food? Raise your hand if you've eaten. How many of you like food that's spoiled? No. What comes on the date for all, what comes on all the packages of food you eat? Expiration dates. Where did they get that date? Because they know what's in the food and how long it takes it to grow at a point where maybe it's not safe to eat it anymore, right? True? If it's refrigerated. If you buy milk, it has a date. You've all had that little brother that stuck it back in there after it was bad and you took a drink, right? We don't like that. But we have to figure out who at the manufacturing plant, they have to figure out what's in the food and how long it's safe. Okay, last one, the half-life. Okay, I'm going to write my half-life formula down. It's really the same as this one, right? Except since it's half instead of double, we're going to do half. And then we'll say, we'll call it the half-life. So the half-life of a certain radioactive substance is 20 days. There are 15 grams present initially. So IO equals 15 grams. When will there be only 7 grams left? So A equals 7 grams. They want to know time. We're looking for time. So let's plug that in, right? 7 equals 15, 1/2 time over 20. Immediately when you see this formula, what do you know? What tool are we going to have to use? We're going to need logs because we have a t up there in the exponent. Can we get rid of the 15 to start with? Yeah, I could say 7 over 15, right? Because I could divide both sides by 15. Of course, I write too big. So now how do we bring this fraction down to the front? We log both sides, right? Whoops. I started to write my 15. That's 7 over 15 equals t over 20. The exponent comes to the front. Now, how are we going to get t by itself? You're going to divide by log 1/2 and multiply by 20, right? So y'all finish that up and make sure that you can get what I got. And that's it. That's what you do with all these.